minus 3 cubed. A, 2 times 3 will give me 6. And B, 3 times 3 will give me 9. Number 6. 2a, open bracket, 5m squared, close bracket, to the index 2. Now, when you study this example carefully, like I told you earlier on, you must have good eyes in maths. So, you can see that this is not affected by the power to power rule at all. So, this is 2a, just like that. Then the 5, and that power goes to 5 and it goes to there. So, it will be 5. Now, you can write like this, times 5 squared m, 2 times 2, 4. So you can write it like that, or you can write it again like this, 2a into 5 squared m to the 4. So I can put a multiplication in between them, or I can use a bracket like that. Right. Let's move on to number 7. Minus 2a, open bracket, 5 squared m squared, close bracket to the index 2. Once again, you can see this is not affected by that power 2. So, you just write that there. And then I'll write the rest of the answer inside the bracket there. Now, that 2 goes onto this factor, and it goes onto that. So, it will be 5, 2 times 2, 4, m, write down m, 2 times 2, 4. Alright, for the rest of the answers, I'm going to move on to that side of the board. Number 8, open bracket, 5m squared times 3m. So that will give you 5 squared m squared times 3m. Now in this particular example, you see 5 squared is 25. Because you can see that this base and that base is the same. So 5 squared is 25, there's your m squared and there's your 3m. Now if you look carefully, 25 times 3, 75. This is m squared, this is m, so it will become m cubed. Number 9. 3ab all squared into ab. So this will become 3 squared a squared b squared. You know why, right? By now you are used to this now. Times ab. So 3 squared is really 9. Now a squared and a will give you a cube. Number 8. Now study number 8 carefully. You got open bracket 5m close bracket squared times 3m. So I'm going to do this down this way. So you can see this power, this is a power to power. Index here is 1, index here is 1. So this power only affects this bracket, not that one. So 5, 1 times 2, 2. M, 1 times 2, 2. So this answer is now written in a bracket like this, and 3m is written next to it. But now when you have a look at this step here, you can see this is m squared and this is m to the 1. The bases are the same. So you can use the multiplication law of powers. So 5 squared firstly is 75. There's your m squared, there's your 3m. So that 5 squared are made, sorry, not 75, 5 squared is 25. So I've converted 5 squared into 25. Now when I look here, I got 25 times 3, so I can make it 75. Now I've got m squared here and I've got m to the 1. These are powers, the bases are the same. Therefore I can write down the base ones. I'm multiplying them now. Therefore I can add up their indices. 2 plus 1, 3. You see this part here, I could have written it like this. 25 m squared times 3m to the 1. So it's 25 times 3 is 75, m squared times 1. Well, m squared and m, write on the base 1 time, add the indices 2 plus 1, 3. Alright, so that finishes number 8. Let's have a look at number 9. Number 9, open bracket 3ab all squared times ab. Now, once again, you got power here, but that's 1, so you don't have to worry. But you got 3ab here, and you got the power 2 here. You got power to power, so you're going to use the power to power rule. Now let's understand the index here is 1, the index here is 1, and the index there is 1. So power to power rule will give me, and this answer I'm writing in the bracket, will give me now 3, 1 times 2 is 2. A, 1 times 2, 2. B, 1 times 2, 2. That one I'm just rewriting it there. Now when I look here, when I'm looking here, I can see, look, this is 3 squared, I can just make it 9. And I've got a squared, b squared. And here I've got ab. Now brackets means you multiplying. And then when you look again, you see, look, the bases are the same, the bases are the same. Now in this step, I can use the multiplication law. So there's your 9, there's your base A, there's your base B. There's 2 here, and there's 1 there, you can add it up, you get 3. 2 here, 1 here, add it up, you get 3. So that's your final answer for number 9. Alright, so what we did is we started with power to power law, and then when we had a good look here, we found that we could even use now the multiplication law because we had powers here and the bases were exactly the same, they were being multiplied, so we could then use the multiplication rule and get this answer. Alright, we're going to move on to number 10. Number 10, we have open bracket 5a squared all squared into 2a cubed all cubed. Now in this example, you got the power to power rule working 2 times. 1 time and there's another time. So let's do this one first. Using the power to power rule, that's 1. So it will be 5, 1 times 2, 2. Then 2 times 2, 4. So I've used the power to power rule here. Now here, this is also power to power rule. So I use the power to power rule there now. Now that's 1. So there will be 2. 1 times 3 is 3. There's your A. 3 times 3 is 9. Now when you look at this step, you realize, well, look, 5 squared is 20, 5a to the 4. In maths, it's always nice to do your work step by step. 2 cubed means 2 times 2 times 2. That gives you 8. Now, when you look here, you got a number times a number. Now 25 times 8 gives you 200. And when you look at A4 and A9, these are 2 powers. The bases are the same. They are being multiplied. Therefore now you're going to use the multiplication law here. So you write on the base A and you're adding 4 plus 9 and you'll get 200 A to the 13. So in other words, in this example, we started with power to power law. We came down here. Then we just decided to simplify 5 squared, simplify 2 cubed. And then when we looked here, we realized that we could use the multiplication law. So we wrote on the base 1 time and added the indices. Alright, so that brings us to the end of exercise 8. Now in the next exercise that you're going to get, in exercise 9, you're going to use all 3 laws together. It's going to be either multiplication law or division law or power to power law. So once you finish marking this, then you can have a look at exercise 9, and you're going to try exercise 9 where you're going to use all 3 laws one time. Alright, before you do exercise 9, you need to have a summary on power rules. There are basically 3 rules that you know. Firstly, the multiplication rule. You add the indices. For example, a squared times a cubed is equal to a, 2 plus 3, a to the 5. Then you've got the division rule, where you've got to subtract the indices. For example, a to the 5 divided by a squared, write down the common base a and subtract the indices, and you got a cubed. And then rule number 3, which is the power to power rule. So here you simply multiply the indices. For example, a to the 5 all cubed, power to power, write down a, 5 times 3, a to the 15. So before you do exercise 9, you've got to have this clear in your mind. And when you're doing exercise 9, ask yourself, am I multiplying? Am I dividing? Or am I going to use power to power? So these 3 rules are now going to be applied in exercise 9. Alright, let's move over to exercise 9. Alright, so here's exercise 9. And as you can see, number 1, 2 and 3, number 1 you're going to use the multiplication rule. Number 2 you're going to use the division rule. And number 3 you're going to use the power to power rule. So be careful, read the question carefully, and then work the exercise out. Right, number 1 is 2 squared times 2 cubed. Number 2, a to the 4 divided by a squared. Number 3, open bracket, 5a squared, close bracket to the index 2. Number 4, open bracket, a squared b cubed all squared. Number 5, a squared b cubed divided by ab. Number 6, a squared b cubed times ab. Number 7, 5a squared b cubed times 10a squared b squared. Number 8, 18a cubed b cubed divided by 2ab squared. The answers to exercise 9. Number 1, you had 2 squared times 2 cubed, right? So write down the base one time, add the indices 2 plus 3, you get 2 to the 5 using the multiplication law. Number 2, a to the 4 divided by a squared. Now you have to use the division law. Write down the base one time and subtract the indices, so you get a squared. So you see, there you use the multiplication law, here you use the division law. Number 3, 5a squared all squared. Clearly this is power to power. So the index here is 1. We're going to multiply there and we're going to multiply down here. Right. So there's the 5. 1 times 2, 2. A, write down A, 2 times 2, 4. So you see, multiplication law, division law, power to power law. So you must read the questions and be careful. Number 4, a squared b cubed all squared. So again, it's power to power. Write down the bases. So it will be 2 times 2, 4, 2 times 3, 6. Power to power law. Number 5. A squared b cubed divided by ab. Well, this is division, so we can use the division law. Now there's an a and there's an a, so write down a. There's a b and a b, write down b. Now the index here is 1, the index here is 1. So for a, it will be 2 minus 1 because we're dividing. So 2 minus 1 gives you 1. Then for b, it will be 3 minus 1. 3 minus 1 will give me 2. So here we use the division law. Number 6. A squared b cubed times ab. Now I have to use the multiplication law. Write down the common base a. Write down the common base b once. Now 2 plus this 1 gives me 3. 3 plus this 1 gives me 4. See, these two examples look the same, but this one is dividing. So you use the division law, you subtract it. This one is multiplication, so you have to add the indices. So you must have good eyes for maths. Number 7, 5a squared b cubed times 10a squared b squared. Well, you multiply. Number times number, 5 tens, 50. The base here is a, the base here is b. 2 plus 2 will give you 4. 3 plus 2 will give you 5. Number 8. 18 a cubed b cubed divided by 2ab squared. Well, 18 divided by 2 will give you 9. A cubed a, just write down a. B cubed b squared, just write down b. Now you're dividing, so you've got to subtract the indices. 3 minus this 1, which will give you 2. 3 minus this 2, which will give you 1. So that's the end of exercise 9. And as you can see, here we have to apply the multiplication rule, here we have to apply the division rule, here we have to apply the power to power rule. So read your questions carefully and see which rule applies. Alright, so we stop there on solutions to exercise 9. Hi there. So what have we been doing so far? Well, we've done introduction to algebra, we've discussed terms, factors, power rules. We now know how to add terms, we know how to subtract terms, we know how to multiply terms, and we know how to divide terms. Now we're going to move on to a little new section, and we're going to learn a few more new words that you need to know in algebra. So the words we're going to concentrate on today are expression and equations and monomial and binomial and trinomial, etc. So now if you're worried, just relax and follow what's happening on the board and everything will be okay. Alright, let's go move. Okay, we're going to talk about expressions and equations. Well, in maths, when you're learning maths, it's always nice to move from the known to the unknown. So you have been dealing with equations before, so let me make that clear to you. You have been dealing with equations, so you know that an equation is 2x plus 3 is equal to 7. Now that's an example of an equation. So, an equation always contains an equal to sign. So an equation always contains an equal to sign. You see that sign there? It's an equal to sign. So that's what an equation is. So what is an expression? An expression is just a number of terms written together. Let's take an example. Now here there are 3 terms. So now you'll understand why we were explaining what is terms earlier on. Now here we have 3 terms. The 3 terms are written together and there is no equal to sign over here. That is why this is called an expression. Now an expression can have 3 terms. If you take this expression 5x minus 2, it's got only 2 terms. Then you can take an expression like this, 5a squared b. This is an expression with only 1 term. This is an expression with 2 terms, expression with 3 terms, and then I could write a plus b plus c plus d. Then this is an expression with 4 terms. So you can have an expression with any number of terms. Okay. Now, expressions are given special names. So I'm going to move on to that now on that side and explain to you when does an expression get a special name. Right, so let's have a look at a number of expressions. Let's say I wrote only x here. Then this expression is only got x in it. So the number of terms here is 1. And a special name given to an expression like this is monomial. Monomial. See, the word mono means 1. The word mono means 1. So monomial means that this expression got only 1 term. Let's take another example. X plus 4. Now this expression has got 2 terms. So the number of terms is 2. And it's got a special name. Its name is binomial. Now just like a bicycle has 2 wheels, this expression has 2 terms. That's why it's called binomial. Right. Number 3. If you look at this expression, x squared plus 5x plus 3, it's got 3 terms. So the number of terms is 3. And it's got a special name called trinomial. When you were a little kid, you played on a tricycle. And it was called a tricycle because it had 3 wheels. So this one has got 3 terms. That's why it's called a trinomial. Now, if it's got 2 terms or 3 terms or more than 3 terms, then all of these together, so in other words, got 2 or more terms. All expressions with 2 or more terms is called a polynomial. Poly means many, right? So if you've got expressions with 2 or 3 or 4 or more, as long as it's 2 or more terms, you can call it a polynomial. But a special name for 3 terms is trinomial, 2 terms binomial, 1 term monomial. 2 or more terms together is called a polynomial. Alright, so that clears our understanding about what is an equation and what is an expression. So you will get an exercise where there will be a number of expressions. You will be required to count up the number of terms and you will be required to give us the names. So let's do a little exercise. Now, just before you do the exercise, you need to be very clear in your mind about a few things. You see, in an example like this, there is no problem. You can see clearly that there are 3 terms. And therefore, this will be a trinomial. But the following is considered as 1 term. The following is considered as 1 term. So, just watch the examples I'm showing you. You see, if I give you 5 times 3, this is considered as 1 term. If I give you a divided by 4, this is considered as 1 term. Because the truth is there's a plus sign here. And terms are separated by plus and minus signs. So that's why this whole thing is considered as one term. The truth is there's a plus sign here and this whole thing is considered as one term. And if I give you a bracket like this, then this whole thing is considered one term. If I give you a bracket like this, never mind it is squared, it's also considered as one term. So these are examples where they are all considered as one term. Even this one here, 5 into m plus a, is considered as one term because there's a plus sign here, and then from here we're moving to look for some other term over here. So let's take an example. If I had 5 plus 3 into x plus 2, and I asked you how many terms here, your answer is going to be 2 terms, because 5 is one term on its own, and then this whole thing is considered as one term, so that's the other term, and that's why we say 2 terms. If I do another example, suppose I had x squared plus 5 into x minus 3, and I asked you how many terms here? Minus 2, as it stands. If I asked you how many terms here, just by looking at it, right now there's 3 terms, you see? That's x squared is one term, then from here, 2 there is considered another term, and that's a third term. So this is your first one, x squared. Then your second term is all this, and then that's your third term. So you need to be clear about this before you do the exercise. Alright, so in the exercise you'll have to use this knowledge. Alright, so now let's get to the exercise and have some fun. Alright, we're here at exercise 10. In this table you are supplied a number of expressions. You are required to tell us how many terms in each expression and tell us the special name for the expression. Don't worry about the last column for the moment. Just fill in the number of terms in this column and the name for each one. Alright, I'll read the questions out to you. 1.1, 3x. 1.2, 5x squared minus x. 1.3, 5x squared minus x minus 3. 1.4, 5x squared minus x minus 3 plus a. 1.5, 5x cubed minus x squared minus open bracket 3 plus a close bracket. 1.6, 2x plus a divided by 2. 1.7, 5x plus 3x cubed plus x to the 4 plus x squared plus 1. 1.8, x plus x squared plus x cubed plus 3 dots, which means that it continues and there are a number of terms after x to the 4. So here are the answers to exercise 10. 1.1, there's only one term and the name is monomial. 1.2, the question was 5x squared minus x. So there's 2 terms and this is a binomial. 1.3, 5x squared minus x minus 3. So there's 3 terms here. So this is a trinomial. 1.4, 5x squared minus x minus 3 plus a. Now there's 4 terms here. So we only got names for 1 term, 2 term and 3 term. Therefore the name we have to use for this one is polynomial. Polynomial. 1.5. The question is 5x cubed minus x squared minus 3 plus a. So, well, actually the number of terms here was 4. So if you look here now, this is one term, that's another term, and this whole thing will be considered as one term. So the number of terms here is 3. Okay? So let's check that again carefully. See? That's one term, minus x squared is another term, and then minus this whole thing will be considered as one term. So the number of terms here will be 3, and your answer will be trinomial. 1.6. 1.6, the question was 2x plus a divided by 2. So this 2x is one term and a divided by 2 is another term. So there's two terms here, number of terms to binomial. 1.7, you've got 5x plus 3x cubed plus x to the 4 plus x squared plus 1. So the number of terms here is 1, 2, 3, 4, 5 terms. Now we only got special names for 1, 2 and 3. So if it's 5 terms, I'll have to call it polynomial. And 1.8, x plus x squared plus x cubed plus x to the 4, and these 3 dots means it continues, therefore it's got more than 4 terms. Well, in the end it means it's got more than 2 terms, therefore the answer is polynomial. Alright, so you must be able to count up the number of terms and then say whether it's a monomial, binomial, trinomial or polynomial. Alright, so that will bring us to the end of answers to exercise 10. And then we'll move on to the next small section called degrees of expression. So let's move on to the next section. Back. Now we're doing a little section called degrees of expressions. Now let's take an example. If you take example 1 and you look at it, it is an expression in x. That's how we talk. This is an expression in x. That's how we talk. This is an expression in x. Now, because there's only one letter in it, x, appearing 2 times. So now, when you study the indices, then you see the highest index here is 2. The highest index is 2. Therefore, we say that this is an expression of second degree. You see, there's an expression, we study the indices, we look for the highest index. The highest index is 2. Therefore, this is an expression of second degree. So if you look at number 2, x plus 3, this is an expression in x. The highest index here is 1 because we're looking at the unknown. Remember, when we're looking at the index, we look at the index of the unknown. X is called an unknown. X is called an unknown. X is also called a base. So x is called a base, or it's also called unknown. So we're looking at the index of the base, and the base over here is x. So this is an expression of first degree because the index is, because the highest index is 1. Let's take another example. X cubed plus x squared plus x plus 5. Then clearly this is a third degree expression, because the highest index here is 3. Now you must be careful. Don't just look on the left hand side. Watch this example. So if you look at this example, you will have to read it from left to right. It is an expression, and it's an expression in x, and the highest index is 4. So that's why this is a fourth degree expression. So when we ask you what degree of expression is it, you're going to look for the highest index of the unknown or the highest index of the base. And then, now we're not talking about numerical bases, we're talking about bases which are letters. Now let's make it a little complicated. Now you can get a question like this. Now we have an expression in x and y. Now we've got an expression both in x and y. So if I ask you a question, what is the degree of this expression in terms of x? That means you must look for the highest index of x. So the degree of this expression in terms of x is second degree, because if I study all the x's, the highest index is 2. Now the same question, what is the degree of this expression in terms of y? Now, if they ask me this question, or if I ask you this question, now in terms of y, then you must study the y's and see what is the highest index of y. So the degree of this expression in terms of y is third degree, because the highest index of y is 3. Alright? So here are some simple, straightforward examples. Sometimes we can complicate it a little bit like this, but the question then will have to be clear to you. What is the degree of this expression in terms of x? Then you look at the x's, find the highest index. Highest index is 2. Therefore, this expression is second degree in x. Same question. What is the degree of this expression in terms of y? It is, in terms of y, there's y to the 1, y squared, y cubed. So in terms of y, it is third degree in y. So we must be able to do some examples like this. So I'll create a little exercise for you now, and you will merely have to say whether it's first degree, second degree, third degree, fourth degree, etc. Alright, so let's get an exercise ready for you. Alright, so here is exercise 11. In each case, tell us what is the degree of the expression. Number 1, 5x plus 2. Number 2, x squared minus 7x plus 2. Number 3, x cubed plus 5x squared plus 3x minus 2. Number 4, 4 plus 3x plus 5x to the 4 minus x cubed plus x squared. Number 5, x cubed y plus x squared y plus x plus 3. Now in number 5, 5.1, what is the degree of expression in terms of x? 5.2, what is the degree of expression in terms of y? Alright, so I trust you now, and I am not saying to you to switch off the DVD. I trust you, and I'm sure that you do that always. Switch off the DVD, work out the exercise, and then wait for us to supply you the answers. Alright. Right, your answers for numbers 1 to 4. The highest index of x here is 1, therefore this is first degree. The highest index of x here is 2, therefore this is second degree. The highest index of x here is 3, therefore this is third degree. Now in number 4 you got to be careful, you got to study the unknowns, you see. It's an expression in x and the highest index is 4, therefore this is fourth degree. Alright. So we go to 5.1. 5.1 we want the answer in terms of x. So we study all the x's and we see what is the highest index for x. In terms of x it is third degree. 5.2. What is the degree of the expression in terms of y? So we will study the y's. If we study the y's, the highest index for y is 2. So it is second degree in terms of y. Alright, so that brings us to the end of degrees of expression. Alright, we're doing another little section called ascending and descending order of expressions. Firstly, ascending means from smallest to highest, and descending means from highest to lowest. So let's look at an example. Arrange this expression in descending order. Right, what does descending order mean? It means highest to lowest. But highest what? It means, you see, for maths now, for expressions, it means, this means highest index to lowest index. That's what it means in maths. So when we study this expression, the highest index is x squared. So you write plus x squared first. Then you must write the term with the next index in order. So 2 is here. So the next index is x to the 1, minus 7x to the 1. And in the end you write down the number. So let's go through this example again. Descending order means you write the term with the highest index right in the beginning. Then you follow the index or the indices in descending order. This is 2, then that will go to 1. And the number will be in the end. Let's do another example on descending order. Number 2. 5 plus 3x plus 2x cubed minus 1000x squared. Now, when we're talking about descending order, we're talking about highest index or to lowest index. We're not worried about the numbers. We're not worried about the numbers here. We're only worried about the indices. So, what is the highest index in this example? X cubed. So, the term minus 2x cubed will be written first. Then we follow by minus 1000x squared. You see, we're following with the index. We wrote the highest index first, followed by the next index, followed by the next index. You see, 3, 2, 1. It's descending according to the indices, and you put the number in the end. Alright, so we've done, so this one was also in right. We wanted that arranged in descending order. We wanted it arranged in descending order. Here is the answer. Now let's look at number 3. Arrange 5m cubed plus 3m squared plus 2m minus 10 in ascending order. Now you've got to understand, ascending order, you must now, for ascending order, you must first write the number and then the powers. Now you see another name for this number here. You see, I'm saying number. The number here is minus 10. Another name for this minus 10 is constant. So minus 10 is the number, or minus 10 is the constant. That's another name. That's how we talk in maths. We say, what is the constant in this expression? The constant is minus 10. Well, it's called constant because you can do what you like. Minus 10 will remain constantly minus 10. It doesn't change. It is the same. Right, now let's see. So, if we want to arrange something in ascending order, first we're going to write down the number. So what is the number? The number is minus 10. So there's the solution or the answer. Right. So first we're going to write down minus 10. So write the number down first. Then you follow with the lowest index and you move up. So what's the lowest index now? Plus 2m. You see the index here is 1. Then you follow with 3m squared, and then you follow with 5m cubed. So now you will see that we're going from number, index is 1, 2, 3. So in ascending order, you'll always start with number, and then index 1, index 2, index 3, etc., and move up. So in summary, let's have a look at these two examples. If it's descending order, you'll start with the highest index, 3, and then move down 2, 1, then to a number. If it's ascending order, you'll start with the number and then move up with the indices, 1, 2, 3. Alright, so that's what ascending and descending order are. Most of the time in maths, we arrange things in descending order. Most of the times, we arrange things in descending order. So I'm going to give you a little exercise now for you to arrange expressions in descending and ascending order. Alright. Alright, let's do one more example before you go to the exercise. Look at this question. Arrange x squared plus 5 plus x 4.1 descending and 4.2 ascending. Now, the same expression x squared plus 5x, x squared plus 5 plus x, same expression can be arranged two different ways. If you want it descending, then this answer will be x squared plus x plus 5. Same one in descending order. Now I can take the same one and write it in ascending order. So ascending order means I must start with the number. So the number will be 5. Then I'll follow by the lowest index, which is x to the 1, and then I will move up. Alright? So what we're seeing over here is one expression arranged in descending order, then the same expression arranged in ascending order. So it is possible to arrange something in descending order and the same thing to go and rearrange it in ascending order. But like I told you in maths, most of the time we arrange it in descending order. Alright, we'll move on to the exercise now. Alright, so we look at exercise 12. We want to arrange the following as required. Number 1, 5 plus x squared plus 3x. Firstly, arrange it in ascending order, and then secondly, arrange it in descending order. Number 2, 5 plus 3x plus 2x squared plus x to the 4. Firstly, arrange it in descending order, and secondly, arrange it in ascending order. Alright, switch off the DVD, try it on your own, and wait for me to supply you the answers. Alright, so here we have the answers for exercise 12. The first example you had was 5 plus x squared plus 3x. Let me just check that. 5 plus x squared plus 3x, yes. So you have to first arrange it in ascending order. Ascending means I must start with the number. So the number is 5, so there's 5. And then I must take the power or the unknown with the lowest index. So it's x to the 1, and then move up x squared. Then the same example, you had to arrange it in descending order. Right, descending order means look at the question and start with the highest power. So the highest power is x squared, and then follow by the next power, which is 3x, and then follow by the number. Number 2, 5 plus 3x, 5 plus 3x plus 2x squared plus x to the 4. 2.1. First, they want us to do it in descending order. Descending order means I must first write the highest power here. So the highest power here is, you read them all, is x to the 4. Then you are looking for x cubed. Well, there's no x cubed here, it doesn't matter. You can leave that out. And then you come to plus 2x squared. Then you come to plus 3x. And then you come to plus 5. Same question, you want it in ascending order. Ascending means start the number. So the number here is 5. Start with the number is 5. Then follow up with the lowest power. The lowest power is 3x, you see, x to the 1. So you're starting with 3x to the 1. Then you move up, plus 2x squared. Then you're looking for x to the 3, you haven't got it here, so don't worry about that. Move on to the next one, which is x to the 4. So that's arranging expressions in ascending or descending order. Right? And like I told you, most of the time in maths, we are going to be arranging